For topic 3, we're going to look at graphing the cosine function. So remember, when we're graphing the cosine function, this is different from the unit circle. The unit circle is a tool that helps us understand the angles and their relative ratios or their related ratios or their corresponding ratios, whatever you want to call it. Now we're going to be graphing cosine in the traditional XY plane, okay? So know that we're dealing with y equals cosine x, or you might see it f of x equals cosine x. That's fine. Know that your input values are x in radians, so the x coordinates are now going to be values for radians, so angle measures, and the y, the output value, is the corresponding ratios, okay? So I don't remember, I printed your worksheet a while ago. There may be a typo right here in your table, so be on the lookout for that, okay? I think I had the wrong point typed in initially, so double check and make sure you see this. This is correct right here. Okay, so we're going to do just like we did with sine. We're going to pull out our unit circle. So you need it sitting in front of you unless you have it memorized. Okay, and we're going to look at filling in this table with common points used to graph cosine. Okay, so the first angle is angles, or the first angle. The first column is angles in radians. So those are going to be our input values. The second column is where we evaluate our function. And then the third column is the ordered pair that we can use. Okay. So let me shrink this just a smidge. Okay, so when you have cosine, when you have theta equals 0 radians, you should get that cosine equals 1. Okay, so I had a typo. I think I was copying and pasting and I just didn't catch it. So we should have that cosine of 0 equals 1 and the ordered pair is 0, 1. So if you've got an old version of the worksheet, make sure you fix that. Okay, now when theta is pi over 3, we get that pi over 3 is equal to 1/2. Okay, so pi over 3 is 1/2, so we have the ordered pair, pi over 3, comma 1/2. At pi over 2, we get that cosine is 0. So we get the ordered pair, pi over 2, comma 0. I don't know why it does this shifty thing when I write, but it's not too bad today. Now, when we have 2 pi over 3, so if we have 2 pi over 3 radians, we have cosine of 2 pi over 3, and that equals negative 1/2. So we have the ordered pair, 2 pi over 3 and negative 1/2. Make sure you've got that unit circle sitting in front of you. Next, we're going to evaluate cosine at pi radians. So cosine of pi is equal to negative 1. So we get, I'm going to put a 0. We get pi, comma, negative 1 as a point. Next, we're going to look at cosine of 4 pi over 3. So cosine of 4 pi over 3 is equal to negative 1/2. So we have 4 pi over 3, comma negative 1/2. At pi over 3, we have cosine evaluates to be 0, or I said pi over 3, 3 pi over 2. We get a 0, so 3 pi over 2, comma 0. At 5 pi over 3, we get that cosine is equal to positive 1/2. And then finally at 2 pi, we get that cosine equals 1, okay? So cosine evaluated at 2 pi is equal to 1. Now, in the previous video, we talked about graphing the sine function, and we talked about these 5 key points, okay? We're going to use the same 5 key points method to graph cosine. So what we're interested in is taking the period of cosine, and hopefully you remember that the period of cosine is 2 pi. We're splitting it into 4 regions that have 5 key and very important points. So we're going to split the period into 4 regions with 5 key points. And those key points are always going to represent your x-intercepts, your peaks, and your valleys. Okay, so x-intercepts occur when y is equal to 0. So if we look at this graph right here, we have an x-intercept here and here. So what that tells me, if I look at these gray rows, those gray rows basically represent my 5 key points. Well, this is a beginning, a quarter, the center, the second quarter, not really the second quarter, it's really the third quarter, and then the end. So we have basically the ends of the period, the center of the period, and then halfway between the beginning and the center is a quarter, and then halfway between the center and the end is another quarter. So I always think of it begins, ending, Um, Beginning and ending as the ends, and then the center, those are always going to be the same, and then the quarters are always going to be the same. And in this case, it's the quarters that are the x-intercepts. That's different than sine. In sine, we had the ends and the center being the x-intercepts, so it shifts here. Now, if we look at the other three key points, we have 0, 1, we have pi negative 1, and we have 2 pi 1. So it looks like the max values, the peaks of this graph, are going to occur at 0, 1, and 2 pi. And then the lowest this graph is going to be is at negative 1, and that's going to be our min, which I tend to call a valley. So again, you have a beginning of the period, a quarter, a center, a quarter, and then the end. I call the beginning and the end the ends and the center. So those are always going to be the same. They're either going to be peaks and valleys or x-intercepts, and then the quarters are going to be the opposite. So in this case, our x-intercepts are at the quarters, our peaks and valleys are at the ends and center. So let's graph this. Okay, I'm going to blow this up a little bit so we can see the graph a bit better. Okay, so when we were looking at this graph, our first key point was 0, 1. So at the origin, when x is 0, we're going to be at 1. Okay, the next key point was at pi over 2, and that was an x-intercept. The third key point was pi comma negative 1. That's the center of our graph. And then the next key point is 3 pi over 2. That was an x-intercept. And then the fifth key point was at 2 pi, and it was a peak or a max. Okay, so the graph does something like this. So this represents one full period of cosine. Now, the graph of cosine and sine at a glance look exactly the same, but their x-intercepts and their peaks and valleys are shifted. Okay, so when we see cosine, it does this. All right. So what's really important here is noticing the y-intercept. The y-intercept here is 0, 1. Okay. The y-intercept of sine is 0, 0. So they're like basically the same graph. One is just shifted. Okay. So let's go ahead and fill in some really important information about the graph of cosine. We can see hopefully now that the domain really is all real numbers. And let me show you this on Desmos just to make that like super clear. So if we go back to Desmos, we're going to graph y equals cosine, and then in parentheses, just put x. And let's go ahead and fix our x and y intercepts. So go to the little wrench looking tool in the corner. And let's say we go negative, I don't know, 6 pi to positive 6 pi. I'm not done positive 6 pi. So we want negative 6 pi. I think that is negative 6 pi. Sorry, if you could see my setup, you'd know why I'm typing like garbage. It's my keyboard's far away. So we're going to go negative 6 pi to positive 6 pi. And let's do the step. The step is how we're going to increment. Let's do pi over 2. And then for the y-axis, let's just do negative 2 to positive 2. That way we can see everything. And we'll increment by just 1. So you can see at a glance, this looks identical to sine, but if you look closely, you'll notice that the x-intercept is different. So where we cross not the x-intercept, the y-intercept, well, both, where we cross the y-axis is different, and then our intercepts are different. So our x-intercepts are falling at different places than the x-intercepts for sine. The peaks and valleys are falling at different places for sine and cosine. So if we look from 0 to 2 pi, we have one cycle. If we look at 2 pi to 4 pi, we have another cycle. 4 pi to 6 pi, we have a third cycle, and so on. And that goes forever in both directions. Okay, so negative 6 pi to negative 4 pi, we have a cycle. Negative 4 pi to 2 pi, we have a cycle. Negative 2 pi to 0, we have a cycle. So this makes it really clear that the period of cosine is 2 pi. Okay, let's fill in the table with some important information about the graph. So the domain, hopefully you could see this graph goes forever, left and right, uninterrupted. So the domain really is all real numbers. The range we can see from the graph we drew. So from the graph we drew, we know the highest point on the graph is at 1. The lowest point is at y equals negative 1. And that doesn't change. All of our peaks are going to be when y is 1. All of our valleys are going to be when y is negative 1. So that tells me my range is negative to positive 1. Cosine, for part C, the cosine function is blank and is symmetric with respect to the blank. Well, in 7.5, we discussed whether cosine was even or odd, and we were able to determine that cosine is even, and even functions are symmetric about the y-axis. So if we were to fold this graph along the y-axis, you wouldn't be able to tell the left side from the right side of cosine. Cosine function is periodic with a period of 2 pi. We discussed that just a moment ago. The x-intercepts are and occur at the blank. So when I am writing these questions, I'm thinking, okay, we have ends and centers of the period, and then we have the quarters. Okay, when it comes to cosine, the x-intercepts occurred at the quarters of the period. Okay, and they happened to be pi over 2 and 3 pi over 2, okay, for just the basic cosine function. The y-intercept is the point 0, 1. We can see that from our graph. We have our y-intercept here, okay? And then it says the maximum value is positive 1. Whoops, let me do that in black. The maximum value is positive 1. The minimum value is negative 1. And the maximum and minimum, I call peaks and valleys, occur at the ends and center of the period. Okay, so that is the graph of cosine. So you've now seen just the basic graph of sine, the basic graph of cosine. It's very important that you understand those 5 key points. Where are the x-intercepts for sine? Where are the peaks and valleys for sine? Where are the x-intercepts for cosine? Where are the peaks and valleys for cosine? Because in the next section, we're going to look at graphing transformations of these functions, and it's really helpful if you understand those key points, okay? So one last note here, and this is going to be important in the rest of this worksheet. We have that if the period of sine or cosine functions were to change, so if we extend or shrink our period, which for sure happens, you'll see that in just a bit, if the period changes, the key points are going to change. So the actual value of the key point is going to change, but where the key point occurs doesn't change. So it's really important to understand that for sine, the x-intercepts occur at the ends and center, and the peaks and valleys occur at the quarters. For cosine, it's really important to understand that the peaks and valleys occur at the ends and centers, or the ends and center, and then the x-intercepts occur at the quarters, okay? Because that's going to be really, really helpful when we do these transformations, okay? So next up, we'll look at transformations of sine and cosine.